Inequality is a mathematical sentence that compares expressions. So again, guys, if you don't have a hard copy of this yet, that's okay. You could have either printed it out or write it down on a sheet of paper. If you're an A through K student, you'll get yours tomorrow. So the symbols that we will use with inequalities, we might have a little arrow guy pointing to the right, looks like, or I'm sorry, to the left. Looks like this. That's called a less than symbol. You might have a greater than symbol, a less than or equal to symbol, or a greater than or equal to symbol. Okay. So what we're going to do is we're going to take a look at each one of our symbols, and we're going to write down key phrases that we need to look for, because sometimes they're really straightforward, but sometimes there's more than one good way to say something. I think each one has at least 2 or 3, so we're going to put these in here. So can somebody tell me this first symbol here, right here, what do we call this? Yeah, this is a less than symbol. So if you see the words is, less than, or just less than, I guess we don't have to write the is, we'll just put less than. That is the symbol you use. Another one that doesn't happen quite as often, but can still happen, is fewer than. So you might see less than or fewer than, because isn't less, fewer, right? Those kind of mean the same thing. If I say you have less than $10 or you have fewer than $10, that means the same thing. Okay. What's the next symbol mean? Greater than. Another word we can use instead of greater, if we can use fewer, right? We can use something else for this, which is more. If I say more than. You have to be greater than 15 years old, or you have to be more than 15 years old, would mean the same thing. Now, this symbol is similar to this first one, right? They're both pointing the same direction, but what's that line underneath it mean? Yeah, or equal to. So this is going to be less than or equal to. And there's a few other ways we can write less than or equal to. We can also say at most. And we can also say no more than. Okay. So less than or equal to, maybe you have to be less than or equal to 6 feet to ride the roller coaster. That would mean the same. That means you have to be, you could be 6 feet, but you could be less, right? At most means the same thing. If I say you can be at most 6 feet, that's at highest level, or anything below it is okay too. And then same thing if I say you can be no more than 6 feet, no more than, not more than, right? So equal to or below. Sometimes it helps if you just like put a situation on it, and that'll help you understand the meaning. And then the last one, again, super similar to this symbol, but we have a line underneath it. What's this one mean? Greater than or equal to, good. And if for less than or equal to, we can say at most. For greater than or equal to, we can say at least. Right? So greater than or equal to, you need greater than or equal to $20 to attend the event. You need at least $20 to attend the event. Means the same thing. Another way you can phrase that is no less than. You can have no less than $20 to attend the event. Okay, so those are some different ways you could see that. Any questions so far? No? Okay. People at home, are we good so far? Okay. All right. So write the following sentences as inequalities. We've done this before with equations. We're going to identify our important numbers and our math action words. So part A says 3.5 is less than or equal to -2. So let's first find our important numbers. 3.5 and -2. What else is a number, but it might be a variable? W, yeah, W is another one. Good. Now we need to find our important math action words. Minus. Minus means subtract, right? What else? Yeah, that's a new one. Is less than or equal to. And if you look up above, is less than or equal to means we need to use this symbol, right? All right, so now let's write that. So W minus 35 is less than or equal to -2. If you want, something that might be helpful for you to do is start with your inequality symbol first, like before, how we would start with our equal sign. Start with your inequality symbol first. We know we want to use a less than or equal to symbol, right? And then kind of pick what's going to make the most sense to you. Doesn't it say is less than or equal to -2? So what's going to need to go on the right-hand side? The -2, right? What's going to need to go then on the left-hand side if it says W minus 3.5? Literally W minus 3.5, right? W, put your subtraction sign, 3.5. And it doesn't say to solve, it just says to write. So we'd be done at that point. B, 3 is less than a number n plus 5. Let's find our important math action words, or I'm sorry, our important numbers. Yeah, we got 3. What else? 5, what else? And yeah, plus will be a math action word. Okay, so plus will be a math action word. That means add. All right, thanks, Alex. Alex, remind me tomorrow to show you where to find it on the page, okay? Okay. So is less than a number? That would also be a math action, right? Is less than. And if you look up above, we can figure out what symbol it is. Less than, that's this first one on our table, pointing to the left. I wish I could make my highlighter smaller. I don't think I can. Okay, so now let's rewrite this. I'm going to start with my symbol. We know we need a less than symbol. Oh, so draw that. Okay. 3 is less than a number n plus 5. So 3 is less than, right? If it's saying 3 is less than, should that go on the left or the right? Think about the way you're reading that. Yeah, because it's saying 3 is less than. So you would have your 3 and then your less than or equal to symbol. A number n plus 5. So then what should I write on the right-hand side? N plus 5, exactly. Good. You can always borrow a pencil if you want, Brooklyn. Okay, so this, I'm tired of this highlighter. I'm going to do this with a different color here. Okay, so let's identify in part C. 0 is greater than or equal to twice a number x plus 1. Bailey, where do we have some important numbers in part C? Okay, 0 and 1. What'd you say? What else did you say, Bailey? You said 0 and 1, and then you said something else. Yeah, X would work as well. That's our variable. Good. All right. Dallas, where do we have some important math action words? Yep. Oh, that's for part D. We're on C. Yeah, greater than or well, you forgot the or equal to part, but yeah, greater than or equal to. So that tells us we're going to use this symbol, and then you're right, twice as well. What does twice mean? Yeah, by what? 2. Good. So this means multiply somebody by 2. Good. Hannah, what's another math action word in this sentence? Plus, yeah, that's okay. Yeah, plus. Good. So now I'm going to start with my symbol. It says greater than or equal to, so we'll put our greater than or equal to symbol. Now let's go through from left to right. 0 is greater than or equal to, so should that go on the left or the right? Well, if it says 0 is, yeah, because 0, and then this would physically read 0 is greater than or equal to. Now this is where it gets a little tricky. Twice a number x plus 1. So twice a number x. How would you write twice a number x? Yeah, it would be like 2 times x. Yeah, so you could just write 2x like this. Yeah, good, Mason. And then plus 1, just put your addition sign and then a 1. Good. And then last one, a number b is fewer than 30.4. Jake Sanders, what's an important number in part D? Good. Do we also have a variable that's important? B, good. And then Corey, what about math action words? Yeah, is fewer than. Fewer than, if you again go up to your chart here, fewer than means you would use the less than symbol. So having that chart handy is very helpful. Now this doesn't have much going on, so I'm just going to put my fewer than symbol, which is a less than. And then B is fewer than. So should B go on the left or the right? B is fewer than. So you'd go, yeah. So go think like, B is fewer than, and then 30.4. Okay, solution of an inequality. So a solution of an inequality is a value that makes an inequality true. Yep. If it's a solution, then it works. It makes it true. So example 2, we're going to tell whether -6 is a solution of the inequality. In other words, we're just going to plug it in and check. So if you don't have a calculator handy, I would probably get one. So we're going to take our variable here, -6, and we're going to plug it in where you see other variables, right? Like here in part A, we have C plus 4 is less than -1. So we're going to plug -6 in for 1, or in for C, I'm sorry. So instead of C, you're going to have -6. So when we write this down, we would say -6 plus 4 is less than -1. Do we see what we did there? That I plugged that in where C is? What are you doing, Brooklyn? Oh, do you want? You can come sit up closer if you want. Okay, so -6 plus 4. What's -6 plus 4? -2. -2 is less than -1. Now think about a number line. Is -2 less than -1? Yeah, absolutely. Yeah, visualize your number line. That is absolutely less than, so this would work. So we would say yes, solution. Yeah, yes, it is a solution. Or say just yes, that's fine. Or say solution. No, we're done. We already have we already have the answer. We were just checking to make sure it actually worked. It won't always work. Okay, so let's take a look at B. We want to take our -6 and plug it in for our variable, which is this x down here. So we're going to have 21 over, and then instead of -6, we're going to, I'm sorry, instead of x, we're going to replace that with a -6, and then is greater than or equal to -3.5. Okay, so now 21 divided by -6, is that going to be a nice, pretty whole number? No, that's not going to work out nicely. Okay, so let's just go through. Well, we might need to plug this into our calculator. Go ahead and try it out. 21 divided by -6 in your calculator. That's okay. Yep. Yes, and as a decimal, Mason gave it to us as a decimal, that's -3.5. I think there should be a little conversion button on your calculator. Annalise, I can look at it in a little bit. So -3.5 is greater than or equal to -3.5. What do we think? Does that work? Is -3.5 greater than or equal to -3.5? Yeah, this works because of the equal to, right? If the equal to is not there, this does not work because -3.5 is not greater than itself. But since the equal to bar is there, then we're good. So we would say solution, or yes, solution, or yes, or whatever, indicate to me in some way that it works. Does it? Is it doing that for anybody else? Okay. It, it might just be, it might be when I move. The microphone on this thing isn't very good. So like if I like move my head, it might change a little bit. Is anyone else having issues hearing me? We don't know? Okay, we have no idea. Okay, but yeah, it might just be my microphone, Alex, like if I move a little farther away, you know? Yeah. All right, so for part C, we have 10 is less than or equal to 3 minus m. So in place of this m, right, we're going to put our given value -6. So we're going to plug this in. We have 10 is less than or equal to 3 minus. Now be careful. Aren't we plugging a -6 in here? So shouldn't we have two negative signs? Yep. Because you have 3 minus a -6, right? So when you have a double negative, Annalise said we should change it into addition, and I agree with that. So let's change that into addition. And now let's simplify. You'll have 10 is less than or equal to, what's 3 plus 6? 9. Is 10 less than or equal to 9? Is 10 less than 9? 10 is more than 9, so this would not work. We would say not a solution. Because this is not true. That does not work. And then last one for this part, 4x minus 25 is greater than -2. So we're going to take our -6 and plug it in for our variable, which is right here. Now be careful when we do this. Doesn't this mean 4 times x? So we're going to need to make sure when we plug that in, we have it with as multiplication. So 4, I'm going to put times -6. You could also put this in parentheses if you wanted to, okay? Like if that helps you kind of separate it. I always recommend plugging things in with parentheses. Then -25 is greater than -2. So let's follow our order of operations. What would we do first to simplify? And isn't this parentheses just for multiplication? So what's 4 times negative 6? Yeah, negative 24. Minus 25 is greater than negative 2. What's negative 24 minus 25? Plug it into your calculator if you're not sure. Nope, that would be if it was 24 minus 25. Anybody at home, any ideas? Negative 24 minus 25? Yeah, negative 49. Alex, can you hear me like right now? I'm just curious with like where I am, like proximity wise. Oh, it glitches? That could even just be a Wi-Fi issue. But it could be my Wi-Fi. You know what I'm saying? Like it could be anything like that. Okay. So negative 49 is greater than negative 2. Is that true? Think a number line. Negative 49 and negative 2. Mason did say false. This would not work because when you get into the negatives, right, negative 49 is actually a very low number. Negative 49 is much smaller than negative 2. Think of it like if you were in debt. If you're in debt $49, isn't that a lot more than being in debt $2? Yeah, so this would not work. Negative 49 is not greater than it. So this would be not a solution. Okay, good. Any questions on how to test that? No? Okay. All right, on to the next side. Graphing linear inequalities. The graph of an inequality shows all the possible solutions on a number line. So you might have, you'll have some kind of number line. You'll have numbers on it, obviously. That's what makes it a number line, right? And what's going to happen is you're going to have to decide what kind of circle you want. Sometimes you'll have a closed circle. Sometimes you'll have an open circle. And then you'll shade to one side or the other. And I'll show you how to figure that out in a second. How you shade it is up to you. I like to kind of do like a little squiggle in that direction. Some people like to go in and like scribble all over it and shade it. Some people like to highlight it. Do what works for you. Okay. So couple different things. When you have, don't we have like a bunch of different inequality symbols? Greater than, less than, greater than or equal to, less than or equal to. All those things tell you what your graph should look like. Our graphs are either going to have solid circles or open circles. So and I think I need to reverse this here. We're going to say we're going to get rid of this N. A solid circle is used when a number is a solution. Actually, here, wait. This is confusing. I had this backwards on here. Give me 1 second. Here, I want to reverse these. See these little guys over here? Ignore these. I had those opposite of what they should be. So an open circle we'll do first, and then a closed circle we'll do second. I forgot to fix that. Okay. So an empty circle. Yeah, sorry, I had those reversed. You can just cross those out over here. I redrew them on the left. An empty circle is used when a number is not a solution. Okay, so that's when we have just like a greater than, or a less than symbol. That's when we use those. So we use an empty circle with less than symbols or greater than symbols. A solid circle is used when a number is a solution. So for that, we would use that with like our less than or equal to or our greater than or equal to symbols. An arrow to the left or right shows the graph continues in that direction, and you can do your arrow like with a squiggle or shaded in or however, as long as I can see it. And then always test values to see what direction to shade. So if you're not sure, you can always kind of think about a value, test it out, see if it works. Okay, so we're going to just practice graphing the inequalities. We have y is less than or equal to 3. So first thing I want to do is decide what kind of circle I need. We have a less than or equal to symbol, right? Okay. So if it's a less than or equal to, couldn't 3 be a solution? It's an equal to, right? Anytime you have that equal to bar, this means you're going to use a solid circle. Okay, so at 3, so identify, look at your number line, find the 3. You're going to put a solid circle at 3. Then we need to figure out what direction to shade in. Now, some people tend to rely on the direction that their little arrow is going in the problem. And that's okay sometimes, but it doesn't always work if your if your inequality is flipped around. We'll see that in the next one. If your variable is on the left, then yeah, you can just kind of look at what direction your arrow is going. So this says y is less than or equal to 3. What are some numbers that are less than 3? 2, 1, 0, right? So that means we want to shade in that direction. So shade towards 2. Oh, I over-explain things sometimes. All right, so for part B, we have 2 is less than x. So first, let's look at our symbol. We have a less than sign, right? So should that be open or closed? Open, so put an open circle at 2. So this one would be an empty or an open circle, however you want to think about it. Now, I got a little bit of an issue. What's my issue with how this is written? What don't I like about the order here that this is written in? I do not like that the variable is on the right. Do you guys like that the variable is on the right? No, probably not, right? So when the variable is on the right, what do you think you can do? You can flip it, but if we flip it around, are we allowed to keep our sign going the same direction? No, you got to flip the whole thing around. So we're going to take this and we're going to rewrite this as x is greater than 2. It means the same thing, but doesn't that make a lot more sense when you look at it? Okay. So now x is greater than 2. What are some numbers that are greater than 2? 3, 4, 5. So we want to shade in that direction, which would be to the right. Okay. All right, and then we have 1.4 is greater than or equal to g. Let's figure out our symbol first. If we have a greater than or equal to, do you think we would use a solid or an empty circle? Solid. Okay, now 1.4, is that really clearly on your number line? No, but what should it kind of be between? Well, 1.4 would be between what two whole numbers? 1 and 2. So put it kind of close to the middle of 1 and 2. It's like an estimate. We have to do that sometimes. Okay, now, do I need to rewrite this one, or is this one good the way it's written? It's not. Why isn't it good, Brooklyn? The variable's on the wrong side. So let's take this, we're going to flip it around and make it g is less than or equal to 1.4. We wanted to rewrite that. Remember, when you rewrite it, you got to flip your symbol around. So now g is less than or equal to 1.4. What direction do we want to shade this? To the left or to the right? To the left, yeah, because it says G is less than or equal to. So numbers that are less than would be like 0, -1, right? Things like that. So shade to the left. And we'll get lots of practice with the graphing. This is just the first day with it. Okay, good. Okay. Oh, no, I try to make you guys like make connections with it. Okay, now we're going to go the opposite. I've given you a picture. We're going to write the inequality that goes with it. So first thing I like to do, you know how like with the other ones, we found we put our dot first. We looked at our symbol. We put our dot first. With these, I like to do the opposite. I like to put my variable and my number and then figure out what symbol I need. So because isn't it, it's kind of like the opposite kind of problem. So I like to do it in the opposite order. So let's figure out, so with these, are you given a variable? Does it say what variable to use? No, pick whatever letter you like. You like to use X, use X. You want to use A because your name is Annalise, use an A because your name is Annalise. Okay, whatever you want to use. I'm going to use X. So I'm going to start with putting my variable on my left and the number on the right. Okay, so I'm going to use X. Ooh, except I don't want it to be a highlighter. Okay, so I'm going to put X, and then what number are we going to be using with this problem? Where's your circle at? It's on -2, so we're going to have X and -2. Now we just need to figure out what symbol we need, right? So let's take a look at what's shaded here. It's starting at -2, right? It's an empty circle. If it's an empty circle, do we want the line underneath it or no line underneath the symbol? No line underneath. So that means, okay, so we got to decide, is this a less than or a greater than? Yeah, because isn't it being shaded towards the -3, the -4, the -5? Those are all numbers that are less than -2. So we would use our less than symbol. And also, if you have it set up where the variable is on the left and the number's on the right, you can base it off of the direction that your actual shading is going. But it's always good to double check. Good. Let's look at B. So I'm going to start with my variable, X, and then my number. So let's see. Mason, what number is our dot on in part B? Oh, Mason B. Mason B. Yeah. 1. Okay, so we're going to have an X and then a 1. Now I got to decide my symbol. If it's solid, do we want the line underneath our symbol? Yes, so that means my only options are greater than or equal to or less than or equal to. So look at the direction it's being shaded and it's starting at 1 and then isn't it going up? 2, 3, 4. So would we use a greater than or equal to or a less than or equal to? Greater than or equal to. Good. Part C, we're going to start with our variable and our number. So put your variable, and then Nick Lopez, what number are we at? Where's our dot for C? 48. So we're going to have our X and our 48. We have a solid circle here, so that means it's either going to have to be a less than or equal to or a greater than or equal to. So let's look at what direction we're shading. We're starting at 48 and we're going up. We're going towards 50, 52, 54. Yeah, which one did you say, Annalise? Yeah, greater than or equal to. Very good, because we're going up. And then last one, part D. Get your variable and then look at your circle. Alex, what number is our circle at? 52. It is at 52. Now we got to decide our symbol. It's an open circle, so we either need a less than or a greater than symbol. Is this graph going up or is it going down? It's going down. We're starting at 52 and we're heading towards 50, 58, 46, 44. Yeah, and it's empty, so we would go less than. Good. Good. And then we're done with that.